Okay, let's talk about the last video. Now I fixed the frequency and also I fixed the intensity of light. That means I use the same brightness. Okay, I fixed the brightness. The light I fix, everything about the light I fix. I fix the brightness. I fix the type of light. I use the same type of light. I use the same brightness. Okay, so I use about the light I fixed already. Now I only change the metal surface. The metal surface I change. Different metal. Maybe look at the video. Look at this one. Okay, about the work function. I control the work function. So now I use first I use the same type of light. Okay, what changes is just the metal surface, the cathode. I change the cathode. Change the metal on the cathode. So the first one, maybe I use rubidium, and then next one I use the thorium, calcium, and magnesium. I change the metal surface. Different metal has different binding energy, different work function, different threshold frequency. Okay, different threshold wavelength. Some bind the electron very hard. Some bind the electron very hard. Some bind the electron loosely. Mostly the very reactive, how to say, very reactive metal, they has low binding energy. But very inert metal like gold, there's very high binding energy. Very high, very hard to eject the electron. Okay. So look at this one. You see. So you can see which one has higher binding energy. Just look at what changes. So since I use the same brightness, intensity just 40%, yeah, same brightness, means the current is the same. You see, all the current is the same. All the current like 27.33, all the current is the same because I use the same intensity. Intensity just affect the current. So the current is constant because the intensity is constant. Okay, so the saturation current also constant, but what changes is the stopping potential only. You see that when I change the metal surface, it changes the stopping potential because some metal bind electron very hard to release the electron. So okay, maybe you can imagine like this. You see this one. Which one do you think bind the electron very hard and very hard to release the electron? Very hard. It should be this one lah, isn't it? It should be this one. This one it bind the electron very hard to release the electron. Yeah. That's why the electron ejected has very low kinetic energy. End up they need a very small stopping potential. But this one, this electron ejected is very energetic. That means an electron ejected very energetic. That means it bind very loosely. It bind loosely, so electron ejected still have a lot of remaining energy. So you need a high stopping potential to stop it. What I can say, just make this analogy, yeah. So what you can see over here is you use the different metal surface, you use a different metal, you will change the stopping potential. That's it. You will change the stopping potential, but you don't change the current. In saturation current, you don't change. Okay. Maybe we look like this way, yeah. Maybe look back to this diagram. Okay. This analogy. Look at this one. Yeah, look at this one. Now, the work function is like the show ticket, the how to say, the price of the show. Let's say I have now I give you 100 ringgit. I give you 100 ringgit. All right, yeah, I give you 100 ringgit. Now the price ticket is 50 ringgit. So how much energy remaining? How much kinetic energy remaining for your snack? You have 100 ringgit. So you have 50 ringgit for your snack. because this is like your energy of photon, HF. Yeah, this is like your binding energy work function, and this is the Kmax lah. The snack is the Kmax. So the ticket now is priced at 50 ringgit. So you have 50 ringgit for your snack. Okay. Now what if the light I fix, this one I fixed already because I use the same type of light. This one I fix. Okay. The 100 ringgit is fixed, but I change the metal. I change the metal means I change the price of the ticket. Understand? Now what if the ticket now sell at higher price? Why now the ticket sell at higher price? That means now I sell the ticket at 70 ringgit. So 70 ringgit ticket, higher work function. Higher. When higher work function means what? Higher work function. So what is the leftover money? What is the leftover money? It just left with 30 ringgit for snack. 30 ringgit for snack. So lower kinetic energy ejected. When lower kinetic energy ejected, you see what happened when lower kinetic energy injected? At lower kinetic energy means lower stopping potential. Understand or not? You need lower kinetic energy ejected means you are left with little energy. After you pay a lot for the ticket, so you just left with little amount of energy for your snack, little amount of energy as the kinetic energy. So the electron ejected now is very low energy and require low stopping potential to stop it. You require only a very low stopping potential to stop it. Understand or not? Okay. So it's something like go back to this one. Okay, maybe I can give an example of this thief. Is this thief? This thief got the money already. This thief want to escape. He want to escape. He has a lot of energy. Yeah, maybe he has the energy. We can think the thief is like the initial energy of the thief. The initial energy of the thief is 100 joule of energy. 100 joule of energy. 100 joule of energy. But the thing is, he need to climb over a very high wall. So the wall will cost him 70 joule of energy. Let's make it even worse. Let's make it 90 joule of energy. Cost 90 joule of energy. So what do you think after climbing the wall? Do you think the thief still very energetic? The thief is very tired already. Very tired already. I don't know how to draw the maybe I just draw a sad face. I draw a sad face. Very tired already. Yeah, very tired already. Okay. So it's very tired already. It left only with kinetic energy 10 joule. Yeah, because 10 plus 90 is 100, isn't it? So initially you have 100 joule of energy, but after climbing the work function wall of 90 joule, this is actually the binding energy. You know that this is the binding energy of the metal surface. So you left over with only, after overcome the 90 joule of binding energy, you left over with only 10 joule to escape. Very tired. So the police come and catch you. The police can easily catch you. The police easily catch you. Okay, because you don't wear a mask. No, the police easily catch you because you are tired. So you require, because since the police easily to catch you, the stopping potential to stop you is very low. Understand or not? Require a very low stopping potential to stop you. Yeah, you require a low. Yeah, that means less effort lah. We can say the police need only less effort. No need to run to catch you. No need to run. You cannot run anymore. After you climb through a very high wall, you have no more energy to run. So the police has less effort, use less effort, use less stopping potential to catch you. Because you only left with kinetic energy 10 joule. So when very high work function, has very low kinetic energy. Understand or not? This is about the metal. The work function is about this thing is what we call the metal surface. Alright, so hold on a second. I just lose connection. Okay. I continue with the next video. Alright, because I need to show my face. Alright.